take 3 rods. Actually, there's a copper. Initially, they are at theta 1 degree Celsius. They're having same length. Then alpha C, alpha S, alpha C. Then YC, YS, YC. Okay, they're at natural length. They're at natural length. I will rise the temperature. They're not placed one upon the other. They're welded like a bimetallic strip. They're welded here. They're welded here. Then definitely if I rise temperature, so what will happen? The copper will expand more because alpha C is greater than alpha S. The copper will expand more. The copper will expand more. So they are at natural length. Let me explain the question. The steel rod is welded between copper rods as shown. The length of rods is L at theta 1 degree Celsius. Fine. Find the increase in length of rods when temperature is raised by delta T. When temperature is raised to theta degrees Celsius. What is L? L is the length of the rods, length of the rods at T1 degrees Celsius. Able to understand bimetallic strip. See, if they are not, if you just place one upon the other, if they are stacked like this, they will expand naturally. But since they are welded, no, so the copper, what happened, will expand more than steel. So what is the basic idea now? So initially they're at natural length. So now I'll rise the temperature. So as I rise the temperature, so what we expect is the copper wants to expand this much. So the copper will expand this much and this will be the steel will expand till here. Now you can ask questions. Why copper will expand? Because alpha C greater than alpha S. They're sandwiched, no? So let me assume a situation of like this here. So this is what, so what we can say delta LC. And this will be delta LS. Okay, there's a diagram what we have. This is what we think. Okay, sir, fine. This is a natural length. If they are free to expand, it would have been, this will be the case. So what is this diagram? If the rods were free to expand. So now initially they're at natural length. They're at natural length. So no stress. No stress in rods. Now they are at natural length. So now also what happened? No stress. Because when a rod is at natural length, no stress will come. So sir, why again you are bringing stress idea? I think there's a key concept here. Now there's a length of the rod at theta 1 degree Celsius. I'll raise the temperature. Then what is the length? Let it be say like a L. Now it has become L dash. No stress, no thermal stress will be there. But at theta 2 degrees Celsius, if you don't permit it to expand, tell me what will happen. If you don't permit it to expand, or if you permit it little bit, but you don't permit it fully. Now, what should be the length of the rod at? So I'll see the concept. Try to understand. Rest all mathematics very easy. This should have been the length of this. This should have been the L dash should have been the length of the rod at T2 degrees Celsius. But what you are doing, you're not permitting it, no? So shall I say it is under stress now? So here, so what you can say, no stress. When rod is at its natural length at a given temperature, no stress. When it is not at its natural length at a given temperature, there'll be stress. Getting the idea? Here, zero stress, because again at natural length, it will be no stress. But here what happened at theta 2 degrees, what should have been length? Length should have been L dash, but what you are making? You are making L double dash. There'll be stress. No, sir, I will make the rod only L. No, at theta 2 degrees Celsius, what should have been the length of the rod? Should have been L dash. But what happened? You are compressing it, no, by this much of amount. So again, there'll be stress will be non-zero. So what is the idea of the problem? At a given temperature, if the rod is not at its natural length, stress in it will be non-zero. Finish sure. Now, if the rods were not welded, yes, definitely copper would have acquired this length, steel would have expanded till here copper. But since they are welded, so what steel will do? Will try to oppose. What copper will do? Will try to increase the length of the steel. So both will come to compromise. That they'll come to one compromise, and they'll attain one. They'll attain one length. This is what? Delta L. So this is copper. Rods under stress. Rods are stressed. Why stressed? Because they are not at their natural length. The second diagram would have been, but the second diagram not possible. The reason for that, the copper wants to expand more, the steel will oppose. The steel wants to expand only till here, but copper weapon will pull it. So now what is the state of steel? Steel wants to have this length, but the copper is not permitting. The copper wants to have this length, the steel is not permitting. I'll shade it at least through diagram. You can getting some picture. See, these are diagrams. Huh? Now students drawing diagrams like this and learning what happened has lost. We have lost it, to be frank. I think you look at the book also. In books, no such diagrams are there. So students will think, okay, yeah, fine, we should write equation. So what actually you're doing, you're not learning anything, no, just gathering information and going to IITs. Science is not about information. Huh? So that much I can say. Science is not about information, gathering information. So what is the second diagram? Second diagram, not permitted. Finally, the third diagram is what that happens. So the delta L is what is asking. So look at the third diagram. So what is the state of it? The copper is trying to, the steel is trying to pull the copper rod, no? So will there be any force exerted by the upper part of the rod on this one? So if you look at the steel rod, what are the forces that are acting will be the FC is pulling constantly and the steel rod is exerting a force. This is what happens. So what is this FC, you know? The steel on the steel rod, these two copper rods are trying to pull it towards right. The steel weapon on its own is exerting a force and managing it. And it's in equilibrium, finish short. Rods are stretched, they are not at natural length. Here, if the rods were free to expand, no stress that one. So this is not happen, this is what happens here. So what is the state of steel rod now? The copper rod are trying to pull it towards right, and the steel rod weapon will exert a force such that it will balance these two. So therefore at equilibrium, Fs equal to 2Fc. So what is Fs now? Young's modulus of steel L delta L minus now you have to ask question. What is delta Ls? L alpha is delta theta. What is delta Lc? L alpha C delta theta. Are you seeing here only? I wrote. If the rods were free to expand, the increase in length of the copper rod would have been this much. And the increase in length of steel rod would have been this much. Why we are writing in this way here for steel? Why that stress? Because the stress is, see, like if the steel rod were at this length, no, till here, no stress. But since it was elongated furthermore, no, by this much of length, are you able to notice here? So why that stress? Because this much of more elongation it is having. That's why there is stress. Then copper rod, it wanted to have this much of length at theta 2 degrees. But what happened? This much of length, what happened? We are not permitting it here. Tell me like how much of decrease in length of copper at theta 2 degrees Celsius, this much. So delta Lc minus delta L. The copper rod is having less length than what it should have. So therefore there's a stress. So what is the less length? Delta Lc minus delta L. Steel rod is having more than what it should have at its natural length. So I think solving for delta L will get it. So delta Ls you substitute. So I'll write the answer. You can do later on. Let me go for next concept. Okay, this is the increase in length. Find the increase in length of the rods. I think the thinking should be like this. So there's the idea now. A student must have this background. There's a background is needed. So what is the idea now? When a rod is at its natural length, no stress. When the rod is not at its natural length, then there'll be stress. Okay, fine. This is enough. This is our answer.